Hello everyone. Okay, I'm back again today. I took a break. I was working a bit off camera. So what I decided is I'm gonna put the other project on pause, especially in the background as I start reorganizing myself. I feel like I failed. I feel like I failed a major component of it and I need to go back to the drawing board. There's a lot of sensor development that I needed to do before I just start building it, and I made a lot of mistakes, especially with the circuit diagram stuff. So I'm gonna put that project a little bit to the side, especially for today, because you really need to think a lot, and I didn't want to stream something while thinking and not doing anything, which was like the last two streams was me just thinking about the next steps, which is okay, but it can be a little bit boring, and I think I need to go back to the drawing board before I start streaming the project. That way I have something to show. So yesterday I was able to get one major part of the project working, and that was fun to show, and I was able to get something done. But right now, since I'm facing a lot of problems with continuing that project, I'm just gonna put it on hold, and maybe we could do something a little bit more fun, a little bit more visual. And I haven't gamed in a while either, so this next few streams will be, I think, doing some ROS simulation stuff, learning ROS, getting started with ROS. So just to like shift my mind towards a new project, and let the other one settle down a bit, because I was getting a little bit burnt out working on that one as well. We made major progress, and you saw a lot of the development being done, and at that time I had a clear idea of what to do. This one I need to go back to the drawing board. So now we're gonna go towards ROS, which is basically the robot operating system, which is for controlling robots. I have another project that works with a robot arm, so we're gonna try to simulate that on ROS. I think they have, the actual company that does the robot arm has a ROS model for it. So in the meantime, I'm gonna work on ROS today, at least for the next 2 to 3 hours. I'm gonna set up ROS. We're gonna do ROS C++. I know C++ is a really tough one to. There's just so much that needs to go into a C++ ROS project, and a C++ project in general, and so much code that you need to keep track of. It's not like Python where you just code and you run it and test it. ROS needs a lot. C++ needs a lot of thought to go into it before you actually start coding. The reason why I'm doing ROS instead of Python, C++ ROS instead of ROS Python, because especially with robots, you need a lot of timing, time dependent actions or movements that require very strict timing. So what I'm gonna do is I'm gonna do C++ because it's also 100 times faster than the Python. So we'll see how it goes. Maybe we'll do Python for things that are more like, for example, image processing, stuff like that. But for robotics and microcontrolling and stuff like that, I'm going to stick with C++. So bear with me. I'm going to get started with ROS. And hopefully I'll I'm going to live stream it. It's going to be slower paced than an actual video. Maybe I could try to clip it and ship it so that it's one video to do like a small tutorial, but I'm no means an expert at ROS, so I'm also gonna be learning along with this stream. And hopefully we can become experts in ROS as we continue. All right, so let's go to the screen. Yeah, I was going a little bit crazy. In the last stream, I got nothing done. Nothing done. I mean, I tested the temperature and humidity sensor. That works, but we've tested that before. It was more like the optical sensor that I wanted to test. And honestly, when you go with a sensor that comes a sensor breakout board, you're pretty much confined to the manufacturer of the company. They use like a specific I2C library that they have, and either I need to reverse engineer it to figure it out on how to do it with the Pico, and I don't want to deal with that. I'd rather just get a generic version of the sensor that has much better I just want to get the data from the sensor, you know. I don't want to have to figure out the library that goes into the that goes from the manufacturer, and you have to use their specific library, which is not made for Pico. It's made for Arduino, and I could spend all my time trying to reverse engineer it, but for the time being, I'd rather just focus on finding a different sensor and replanning my project a bit so that I can do it. We'll be back on that topic, but for now I just want to do some more fun stuff, switch my thought process. So today we'll be doing ROS. Today we'll be doing ROS. So bear with me. I'm going to get started. I think I want to do ROS too. So rather than that, let me open my Chrome actually. Okay. So ROS, what is ROS? ROS is Robot Operating System, but it's... Oh, my God. And Mimi's back. I swear, when I'm not working, she does not care. And then when I start working, she's like, okay, you need to pay attention to me right now. ROS. So here is ROS. So what is ROS? ROS is Robot Operating System, but it's not really an operating system. It's rather like a software package that you run on the computer or the processor of your robot. And what it does, it's basically the communication between all the sensors and all the functionality of your sensors and robot actions. So it's a way to do messaging between each component of the robot. So let's say you have like a computer vision part for ROS. You can communicate between your cameras with your actuators. And of course, Mimi wants to... Mimi. Okay, let's get on my back. There we go. So, yeah, like I said, it's basically the communication software between your drivers, your sensors, your whatever, and stuff like that. And it also comes with a software package called Gazebo, which allows you to do simulations and stuff like that. So if you have 3D models of your robot, you can... Okay, Mimi. Mimi. So yeah, let's get started. Let's get started. I think I want to do ROS 2. There you go. So short-term release. I want the long-term release. So look at Mimi here. Alright, Mimi, come on. Mimi, I gotta put you down for a sec while I work. I'm not gonna do too long. I'm probably just going to set it up today and then try to figure it out. So we'll just get started with it, and then I'll do another stream that gets a little bit more in depth with it. I worked with ROS before, but it was ROS 1. So we'll try and figure it out. So come along with me. Okay, so let's install ROS. Binary. Oh. Okay. So ROS is originally for like Linux systems, but I think now it's a bit more cross-platform. I'm sticking with Linux because I use Ubuntu. So let's just get started with that. Alright, so let's do some installations. Okay, so it looks like there's 3 versions of ROS. There's ROS 1, ROS 2, and ROS. Okay. Short-term release. I'm gonna stick with this one. Yeah, okay. So normally you would install this on your robot system. But today, I mean, right now we're mostly going to work on simulation stuff, so we're going to just do it on the computer directly. Okay. god. It's also so hot. So Mimi, you're like a heater. Okay. So before I need to do anything, I'm gonna update everything. Sudo apt update. Okay. Sudo apt install software properties common. Okay. 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 Let's figure this out. Let's figure this out. So we're gonna follow the instructions here. Locale. I don't know why this is important, but okay. Let's do this. Sudo locale gen NUS dot UTF 8. Let's do that. I'm just gonna copy this just so that I don't have any typos. And then locale. And us.utf. Yeah. There we go. Okay, sudo apt repository sudo adapt. Okay. Installing ROS2 app packages will configure ROS2 for your system. Updates to repository configuration will occur automatically when you. Okay. I'm pretty sure I have these, but let's just follow the instructions. Okay. Let's do that. Okay. And I'm going to install the development tools. So it's been a while since I used ROS. I used it last year for a project. So bear with me as I try to figure this out as well. Okay. Now let's... Okay, sudo apt update. Sudo apt upgrade. Okay, let's do that. I hope I don't need to restart, otherwise the stream will end. The installer would like to add Microsoft repository and signing key to update. Sure. Let's do that. Okay, next. Wait, did I install? I don't think I installed. Okay, yeah, I just upgraded. Okay, so now we're gonna do sudo apt install ROS Jazzy desktop. So the middleware that ROS2 uses is FastDDoS, but middleware RMW can be replaced at runtime. Okay, so I guess I don't know too much about ROS2, because what did they use for ROS1? So ROS used TCP, not DDS. Okay. Automatic peer discovery over DDS. Okay, it works with microcontrollers. Alright, alright. So we will learn about ROS. Okay, so ROS Okay, once that installs, we need to set up our environment. And every time that my computer restarts, we also need to source it. So I want to add this to my bash RC. Okay, so this is source opt, but what I'm gonna do, rather than sourcing it, I'm gonna echo source copy this actually. And I'm gonna echo it into dot bash rc. And then I'm gonna source dot bash rc. Okay, I think it's now installed, right? So let's say if you install it. Wait, did I install? Okay, so ROS Jazzy Desktop. Above can try some examples. First use Zeno. Okay. So if I do ROS2, oh no. Shit. Sudo nano. I made a typo. I made a small typo. Opt ROS, not bash. And I'm gonna source bash rc. There we go. So ROS to run demo nodes cpp talker. Okay. And there you go. It's so if I open another one, ROS to run demo. No, oh wait, no. I'm just gonna copy it. Okay, I think I need to install this. Yeah. Scheiße. I wonder if it comes with a... Okay, let's see. Okay, let's see if I do sudo ROS dep init. ROS sudo ROS dep update. Okay. So it's similar to MQTT, except for there's a lot that goes into it. You need to define message types and stuff like that. I don't know about in ROS 2. I think so in ROS 2 as well. But okay, so the talker is talking and the listener is publishing. Okay. That's good. Okay. I don't know what. Install additional middleware. Okay. ROS middleware implementations. Okay, so working with multiple ROS middleware implementations. Okay, let's do this. What is differences in ROS 2 middleware? The communication. Middleware, which provides discovery, serialization, and transportation. This article explains the motivation between using DDS implementation. Okay. RTPS I think is the ROS 1. I'm not sure actually. In summary, DDS is an end-to-end middleware that provides features which are relevant to ROS systems, such as distributed discovery, not centralized like ROS 1. Oh, okay, interesting. And control over quality of service options. So there's fast DDS, Eclipse. Interesting. If ROS 2 workspace has multiple, fast DDS is selected. Okay. Okay, forget it. We need, what is ROS 2 run? Okay, forget that one. Tutorials and demos. Maybe we could do one quick tutorial and demo. Exit, uninstall. No, I don't need to uninstall, so maybe we could run some tutorials in. Okay. So we've installed ROS so far. Like I said, ROS is mostly the communications between nodes. So we need to build packages upon this. So if you give me 1 second. Okay, so I'm gonna be a little bit more. So I'm gonna create specifically for ROS a new ROS. So this is where I'll put like any packages and stuff like that. Right? Hold on, let me see how I used to do it in ROS 1. Okay. So in ROS 1, you used to use catkin make to make a project. But apparently they use something else now. They use something called Colkin build. I am not familiar with this. I'm looking at my old projects and seeing how I used to do this. Okay, let's look at this. So typically the old ROS flow used to be like this. So you would have a catkin workspace, and if you want to source a package, you would link that package. Into your source folder. Right. So you would have a bunch of packages that you can pull into your main source project. Okay. I wonder if it's the same. So let's say I'll have a repository that's my, and I'll have all these packages that I can link into my source. Right. Yeah, that's how it works. So I wonder if it's the same. Okay. Okay, so I'll call this my ROS2 workspace. So this is our main workspace. And whatever packages that we want to make that's separate from the workspace, we just link it into our workspace, and then we can build the system. That works. So it's like a classic C++ project. Mimi's here, by the way, if y'all were wondering. Hello, Mimi. Okay, let's see what examples they have. Maybe I'll do a quick example and then let's see. Maybe I'll go through all the tutorials and we'll see. So configuring your environment shows how to prepare ROS2 environment. Beginner level takes about 5 minutes. Okay, whatever. ROS2 relies on the notion of combining workspaces using the shell environment. Workspace is a ROS term for location of your system where you're developing ROS2. So like I mentioned before, okay, I'm going to show you what we used to do in ROS1. Oh, not this. Let me show you. Yeah, actually, what was that? So in ROS2, we used to have like a work environment. So back then it was a Catkin workspace, but I think in ROS2 it's no longer Catkin. I think it's something else. But I think the idea stays the same. So in your Catkin workspace, so let's say this is your big project. The idea is your project is composed of multiple packages. So let's say you have a package that handles this operation, a package that handles another operation, stuff like that. So ultimately, each one of these packages have their own environment, message types, service types, configurations, if you have models of it. And basically, the Catkin workspace compiles all the packages necessary for the entire project. So basically, you can have a separate package that handles one thing that you could pull into your Catkin workspace. So I think it's very similar. I think it's very similar in that sense. Okay, so what we'll do is we'll follow some of the tutorials. Once I get used to the new environment, I'll just skip the tutorials and jump into the new environment. And like I said, we're using C++. We are no longer using whatchamacallit. Anyway, we are no longer using Python. I'm gonna have to leave at 6, so we'll probably do like one or two tutorial, and then I'll end it there, and then the next one I'll continue. Next stream. Okay, I think we can end this. Okay. Okay, where's the term for? Okay, subsequently local workspaces are okay. The core ROS2 workspace is called the underlay. Okay. Subsequent local workspaces are called overlays. Oh. When developing with ROS2, you will typically have several workspaces active concurrently. Okay. It's a little different. Because I think ROS2, you can work on multiple workspaces and it's distributed rather than one core project like in ROS1. So combining workspaces makes developing against different versions of ROS2 or against different sets of packages easier. It also allows the installation of several ROS2 distributions. On the same computer and switching between them. This is accomplished by sourcing setup files every time you open a new shell or by adding the source command to your shell startup script. Without sourcing the setup files, you won't be able to access ROS2 commands or find or use ROS2 packages. In other words, you won't be able to use ROS2. Okay, yeah, that's what I did. So like I mentioned earlier, I source setup.bash. So before starting this tutorial, ROS2, by following the instructions, the command used in this tutorial assumes you follow the binary packages installation guide. Yeah. You can still follow along if you built from source, but the path of your files will likely be different. You won't be able to use the sudo ROS distro package. Okay. Perfect. So adding source to your shell script. Okay, I already did that. Come on, man. Keep up with me. How about that? And sourcing ROS2 setup files was set several... Okay, what does that mean? Sourcing ROS2 setup files was set several environment variables necessary for okay, so if I want to see what's available in ROS, I just need to do that. Okay. If the environment variables are not set correctly, return to ROS2 package installation section of the ROS domain variable. What is ROS domain? Once you determined a unique integer for your group of ROS2 nodes, you can set the environmental variable with the following command. To maintain settings between shell sessions, you can add commands. Okay. I don't know what ROS domains are. The default middleware for ROS2 is in DDS. DDS is the primary mechanism for having different logical networks share a physical network. In DDS, the primary mechanism for having different logical networks share a physical network is known as domain ID. ROS2 nodes on the same domain can freely discover and send nodes to each other. Okay. Well, ROS2 nodes on different domains cannot. Okay, so you want to set a domain so that all the communications are on the same domain. All ROS2 nodes use domain ID 0 by default to avoid interference between different groups of computers running ROS2 on the same network. A different domain ID should be set for each group. Okay. Okay, so between 0 and 101. Okay. Oh, oops. So platform specific constraints. Okay, wait. The domain ID is used by DDS to compute UDP ports that will be used for discovery and communication. See this article for okay. Remembering our basic networking, UDP port is an unsigned integer. Thus the highest port number that can be allocated is doing some math, the formula in the article. This means the highest domain can, okay, yeah. For maximum compatibility, some additional platforms, okay. In particular, it's best to avoid allocating. This avoids possible conflicts between the ports used in it. Okay, yeah. So it uses UDP. This means domain 0 through 100 and through 1 can be safely used without for each ROS2 process running on the computer, one DDS participant is created. Since each DDS participant takes up 2 ports on the computer running more than 120 ROS. Okay. Okay, interesting. Okay, so from what I understand, basically, domains, what it means is if you want your packages to communicate within the same communications, you should choose a specific domain so that if you have multiple projects going on at once, they won't you can have there's no interference. So projects within the same domain can communicate with each other's, but if they're in different domains, they won't communicate with each other. And because it uses UDP, it's basically the networking communication protocol that establishes ports. So okay. I don't want to set it right now because I want to have a project first before I start setting variables. By default, ROS2 communication is not limited to localhost. Using ROS automatic discovery range is helpful in certain settings, such as classrooms, where multiple robots may publish to the same topic, causing strange behaviors. The ROS2 development environment needs to be correctly configured before. This can be done in two ways, either sourcing the setup files in every new shell you open or adding source command to your startup script. Okay, yeah. Okay. Okay. So we'll start with one. So we're gonna do a turtle sim project. Okay, turtle sim package. So Turtle Sim is a lightweight simulator for learning ROS2. It illustrates what ROS2 does at the most basic level. Okay, ROS2 tools is how the user manager introspects, interacts with ROS systems. Okay. Yes, I remember RQT, graphical user interface, to look at. Okay, this tutorial touches upon ROS2 concepts like nodes, topics, and services. All of these concepts, okay. Good. I mean, it didn't really tell me how to set up my environment, but okay. Okay, sudo apt install ROS Jazzy Turtle Sim. But I would like to see the project, but I mean, okay. So ROS. Okay. Run turtle sim sim node. Okay. So that's one node. Oh, something opened. Okay, so this node. Okay. So I can't do anything with it yet. It just runs the node, which. Okay, okay. Okay, and then open a new terminal. ROS 2 run turtle sim turtle teleop key, right? Okay. Oh, so now I can control it with my keyboard. But why does it say GBV CDERT? Because it doesn't. I can use the arrow. Look at that. Look at that. Look at that robot. Oh wait, can you even see it? I'm blocking the screen. My bad. So there's the turtle sim. And I need this to be able to. Look at that. Maybe do that. What about this one? Let me do a new. Let me do something. Let's see what I can do. Oh. Let's see if I can do this here. Oh, no. No. Go back. Oh, no. There we go. All right, all right. Enough of that. At this point, you're running 3. Okay. Yeah, so these are the important things. So if I okay, ROS to node list. You see, so these are the 2 nodes that are currently running. ROS to topic list. Command velocity, command sensor, ROS to action list. So yeah. Okay. So that's just a quick intro, but eventually we're gonna be developing these nodes and stuff like that. Okay, actually, there's another thing that I want to install. Terminator terminal Ubuntu. So this one's going to be very useful for ROS projects, because in ROS projects, you pretty much need to open a new terminal every time you want to run a specific node, for example. Right? Or package. So I want to install Terminator. How do I install it? Terminator. Okay. So this one's a very useful tool for ROS projects, especially when you're developing ROS projects. So Terminator, it looks something like this, but I can create new windows. I just forget how to do it. I want to make a new window. Oh, okay. I'm just gonna right click. You see, I can split vertically, horizontally. I can move it around. Okay, see? So that's what I like. So this is a nice tool to have. This is a nice tool to have. Just letting you know. Control Shift I. That's cool. New tab. Oh wow, okay, so I can even make a new tab. What the hell does rotate terminal mean? Interesting. Can I rename the terminals? So if I want to close a terminal, that's what I do. Oh, look at that. Okay, that's really cool. Okay, just so you know, Terminator is a Terminator used. Okay. So let's say I want to run these two tabs in the same screen. So if I do ROS2, and then in this one, there we go. So now you can see I have two terminals open. One for the, oh, why does the turtle look like Luigi? Come on. Oh shit. No, 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 no. Woo! Oh, so if I hit a wall, look, it hits a wall. So there's some physics to this actually. There we go. That's what I wanted to do. There we go. Okay. Alright. Enough being stupid. Okay. This is another one that's quite important, the RQT graph. I'm just gonna install it, I guess. Nothing is happening. Oh. Here it is. This is what opened. So if I do what were the commands? ROS node list. There's no if I do ROS node list, oh, ROS2 node list, and what if I do RQT? Okay, interesting. Plugins. That is able to load various plugin tools. Okay, what does it say? Plugin service caller. Okay. So these are all the services spawn. You see? Okay. Okay. Got the point. Okay, we got the point. We want to know, I want to see nodes. Yeah, RQT graph. That's what I want to see. RQT graph. That's the one. Okay. ROS2 run to the same node. Okay, yeah. We have the node list. Remapping allows you to reassign default node properties, like node name and stuff like that. Okay. since you're calling ROS to run. Okay, so okay, yeah. So what do I just do? ROS to graph? It didn't tell me how to run the graph. Okay, yeah. I remember that. There we go, ROS to graph. Why am I getting a lot of messages? Okay. So I'll just do like a quick explanation. So in ROS, there's these things called nodes, and nodes can typically publish to a topic, and nodes can also subscribe to a topic. There's also things called services or even actions, but we'll talk about actions later. But services are like a service that a node can provide when requested that. So you can have a node request. We can have something request a service from a node, and it'll perform an action and a response. Okay, and typically we need to set up service files beforehand, and what type of services they accept and stuff like that. And topics are usually always subscribed to, so we will always know the information that's being published to a topic within these nodes, right? And actually we can even see the graph of the nodes of a certain package or project that's going on. So what we can do is use ROS to run RQT graph. That's the one. This was that's the one that we wanted to do. So these two nodes are running. But it's not saying anything. Yo, YouTube's audio library slaps pretty well. I think I'm gonna use it from now on. Forget all the paid services. Okay, I did that. Oh, did I not? Oops. No, I did that, ROS through. Okay, I just needed to refresh. Okay, so you can see here. These are topics. So these publish to the topics and these ones subscribe to it. And I think that's another topic. Yeah, there we go. That's what it is. Let's see active. Okay. Okay, I think I got the gist of it. Now I want to make my own project soon. Okay, so because I want to use a C++. Okay, this is actually what we want. We want to learn how to use the client libraries. This is actually the more important thing because we want to start a project. But to be honest, I don't want to start it right now. Maybe we start it later. Give me like 10 minutes. I'll be right back. I'm just gonna use the bathroom. And I'll see whether we should actually start a project. But we'll see. I'll be right back. Okay, I am back. I am back. All right. Okay, what I'm thinking is I'm gonna just set up a project. So we just did a quick turtle sim tutorial. It had a lot of information that I feel like is not really necessary unless you're making the project. So what's the point of even seeing this in the command line? So what I'm gonna do is I'm gonna start a project and we're gonna learn about these things as we go on. I need to go soon, but what I'm gonna do is I'm gonna set up a project workspace, and the next stream or the next time we work on ROS, I'm gonna build upon that and learn as we go. Okay, so hopefully that'll be interesting enough. What happened to the music? Oh, next music. Okay. Let me charge my phone. Okay. Woo. Okay. So let's set up a project. I'm gonna make a, as usual, I'm going to make a GitHub repository. I have so many repositories. It bothers me a little bit. ROS2 org template. This is for my reference. Sorry, I'm just doing some logistic stuff. Okay, so I'm used to Catkin projects, but since ROS 2 doesn't use Catkin anymore, or I'm not sure if they use Catkin anymore, I created a new workspace repository. Okay? So okay. Let's start this. I'm assuming it's more or less the same. Me. The heck? No. Your code installation appears to be corrupt. Please reinstall. There we go. ROS 2 workspace. Well, I'm gonna save it. I'm gonna put it under ROS. Oh, just under ROS. There we go. And we're gonna start it here. So this is our workspace. Okay, Mimi, damn. Okay, Mimi, damn. I can't work with you. Okay, Mimi, damn. How can I focus? You're like... Mimi, how can I focus? You always want to cuddle, man. Mimi, come on, get on my shoulder. Get on my shoulder. Okay, get there. Get there. God damn, Mimi. I think I need to get you more toys or something. Okay. I am not using Python. Hello, Mimi. Okay, Mimi. Sit there. Please sit there. Okay. No, I want to use C++. Mimi, please. Mimi, please. Okay. So they use Culkin, I think. It is practical tutorial, not designed to replace the core documentation. Okay. Culkin is an iteration of ROS build tools. Cat can make isolated, Cat can tools, and Ament tools. For more information on design of Culkin, this documentation. Okay. I don't want to use Python though. Do I have to use Python? To build samples, you will need to... Okay. Okay. So there's a build directory where will be the interim files are stored for each package. The installed, where each package will be installed to. And by default, each package will be installed in separate subdirectories. There is no devil directory. Okay. So my directory will have a source src. There's gonna be a build. There's gonna be an install, right? Oh, no. Install. And I'm gonna add a git ignore. And anything within the build is gonna not be added. Okay, let's clone. Okay, and then our src or terminal. What I'm gonna do is within this I'm gonna git okay, git sub module add Let's see, let's do this, get examples. Paste. What the fuck? There we go. Okay. Source and underlay. It's important that we have sourced the environment for an existing ROS2 that will provide our workspace with the necessary build dependencies. This is achieved by sourcing the setup script. Our workspace will be an overlay on top of the existing ROS2 installation. In general, it is recommended to use an overlay when you plan to iterate on a small number of packages rather than putting all your packages in the same place, okay? Call can build. Oh, there we go. Anything in the git ignore. I can also install Okay, so now it's built. Okay. After build is finished, we would see the build log directories. Okay. To run tests for the packages that we just built. Okay, so we run colcan test. So it's no longer catkin, it's colcan. I don't know what this means, but Okay, actually, I'm gonna need to go soon, so we'll continue this after. So we just set up the workspace. Um, okay. So for now, I'm just gonna get initial package architecture. Get push origin main. I'll make a readme too. ROS 2 call con workspace template. Get command update readme. Get push origin main. Okay. So I'm gonna stop right there. So today what we did, especially in this stream, not the previous stream, but in this stream, I just installed ROS 2. We kind of did a quick tutorial using the Turtle Sims. We went over some basic concepts and we just started the workspace. What I'm gonna do from now on is pretty much learn how to build these workspaces and these projects. That's not just an example. So we'll stop it there for now. I just wanted to do a quick stream because the last stream was kind of dud and honestly it wasn't that great. So I just wanted to shift our thoughts towards another project that's a little bit more engaging. So next time we'll start building upon the project. So I'm gonna end it there. Mimi will say bye. Mimi? Mimi? Say bye, Mimi. Okay. Ow. Okay, Mimi, stop. Mimi. Okay. We will see y'all next time. Thanks for watching. Bye.